The mystery of the missing matter, dark, as cosmologists call it, in what could go down in history as the ultimate cement or surrender. This is not dark as in distant or invisible. This is not dark as in black holes or deep space. This is dark as in unknown for now, and possibly forever. 23% something mysterious that they call dark matter, and 73% something even more mysterious that they call dark energy. Dark matter doesn't emit light, it doesn't absorb light or interact with light at all. And scientists did work to make a prediction for this. Both Newton and Einstein said that the more stuff an object has, the more gravitational pull it will have to keep other planets to stay in orbit. And the further an object is from the center, the slower it should travel because the gravitational pull gets weaker as you go further apart. All galaxies rotate too fast for their own good. For that, there is a halo of invisible matter surrounding the galaxies to maintain this motion. This is dark matter, and its mass is enough to keep rotational speed of galaxies constant. Well, how do you know your glasses are there?
Because they distort light.
Dark matter exposed itself by the bending of light that passes through it is called gravitational lensing, and it's the virtual spotlight that uncovers anything or any stuff in the universe. It deflects a light ray in its path. Gravity is really the warping of space-time about an object with mass. Like Einstein said, and I quote, gravity affects everything, just like gravity is caused by everything. So one of the things affected by gravity is light itself. So dark matter is just a matter of you and me, but it's not shiny. So we can consider a couple of things that match the dark matter candidate. Black holes were considered. They don't emit light, can draw matter to themselves by gravitational pull, and are detected by gravitational lensing. Why black holes can't be considered is because there's about 10 times as much dark matter in any large galaxy that there is normal matter that can be observed. If this was all in black holes, then there would be 10 times as many black holes as there are stars. What would happen? Well, common sense. The black holes would interact with other matter in the galaxies, and the effects would be quite catastrophic. Matches were considered massive compact halo objects, which are basically dark small stars that don't give a lot of light. And the reason they cannot be considered is because they aren't enough to account for the total dark matter needed. Ixions could be considered, but theories prove that they change to protons, that their dark matter is constant. The only particle that's left is a WIMP. They haven't been discovered yet, but their characteristics match the perfect dark matter candidate. So we can conclude that dark matter is a different, exotic, unlike anything on Earth, and doesn't interact with anything other than gravity.
Labs and research centers are trying their best to see a dark matter particle. It's tedious, and if they do, then we can unravel some of the biggest questions about the universe, or what happened 1/10,000th of a second of Big Bang. But the plain fact is that they still haven't come across any dark matter particle yet.
Like I said before, the further an object is from gravity, the more slowly it should move to stay in orbit, and the universe expansion after Big Bang must be slowing down. But here's why this idea falls apart. Edwin Hubble discovered the galaxies away from Milky Way are traveling more quickly than the ones near. That's not how it should work, right? Truth is, it does. Thought that he could calculate the velocity of galaxies by studying their wavelength through prism. This is called as measuring the redshift, and is used to measure distances in space. The more distant the galaxies, you're looking at them as they are at progressive distance times in pass.
Space is expanding. It's not the galaxies or stars that are expanding, but the space between them is expanding, and now we know at an accelerated rate. So what's causing all this disturbance? It's called dark energy.
The repulsion is dominating over gravitational pull. In other words, dark energy is dominant over dark matter.
If you plot force versus time, we can see both dark matter and dark energy were created from Big Bang, where for 9 billion years, dark matter slowed down space expansion. The universe grew big enough that dark matter was dispersed, and dark energy took advantage of that and sped expansion and rate.
When dark energy overcomes dark matter, the entire universe will enter a phase called exponential growth. Unless this changes, we are expanding. The fate of the universe is to expand, and we don't know if that's a good sign. Dark energy and the laws of physics is a death warning to all intelligent life in the universe.